This is the video for week 1, topic 3, indices and the law of indices. This is the only video for topic 3. These videos are intended to help you with the basis in arithmetic and algebra that you will need for future topics in this course. Again, it's recommended that you watch this video with your pen and paper and pause at relevant times to try the examples for yourself. Indices and the law of indices. So what are indices? So here we have our expression 2 to the power of 5. Here, and 2 to the power of 5 means it's 2 times 2 times 2 times 2 times 2. So what we have is 5 lots of 2 times itself. So 2 is our base here, and the 5 is the index. So looking at our integers here, we're going to look here, a to the power of n. We have a times a times a n times. So 3 to the power of 5, we have 3 5 times here. So looking at our parentheses and our conventions. So here we have -2 in our parentheses or our brackets to the power of 4. And what that means, it's this whole -2 in our parentheses here times by itself 4 times. We know a negative times a negative is equal to a positive. So if we look, -2 times -2 will be 4 times by -2 and -2 here. So here 4 times -2 will give us -8 times -2, still to go. Negative times a negative is a positive. 8 times 2 is 16 there. For our second example here, we have -2 to the power of 4 here. No parentheses, so this 4 is only acting on that 2. The negative part is outside there. So here, -2 to the power of 4. Here we have negative separate, and then 2 times 2 times 2 times 2 is 16, and our negative sign stays out the front there. Next thing we're going to look at is the power of 0. So here, anything to the power of 0 is equal to 1. So they've said here a to the power of 0 is equal to 1. We're going to put here anything here in our bracket, -1268 to the power of 0 is equal to 1. Anything to the power of 0 is 1. Our next example here is our negative index. So our negative index, here we have a to the power of -n. And what that means, we make this a fraction. And 1 at the top and a to the power of n at the bottom. So here we've got 5 to the power of -2. It's 1 on 5 squared is equal to 1 on 25. Here we have in brackets -4 to the power of -3. So here we have 1 on, in brackets, -4 cubed. We work that through, 1 on -64, and then we can take our negative sign out the front. We have 1, so -1 on 64. The next thing we're looking at is multiplying with our indices. So we have a to the power of n times by a to the power of m. And what we do is we add our indexes. So here we do our example, or we'll do a simpler example. If we have a squared times a cubed, a squared is a times a. Here we've got our times in between these, and a cubed we have 1, 2, 3. We end up with 1, 2, 3, 4, 5 lots of a, which is 2 plus 3. So here we've got a to the power of -9 times by a to the power of 4. So we're adding them together. -9 plus 4 is equal to -5. We could also use our rule for our negative indices here, and we'd have here 1 on a to the power of 9 times by a to the power of 4 on 1 here. So we have a to the power of 4 at the top and a to the power of 9 at the bottom. If we want to work this through, we've got 1, 2, 3, 4 a's at the top, and 1, 2, 3, 4, 5, 6, 7, 8, 9 at the bottom. We can cancel an a at the top and an a at the bottom here until we run out there. So we're left with 1 at the top, and here we've got 5 a's. So here we've got 1 on a to the power of 5 or a to the power of -5. Looking at our next bracket here, we have a to the power of n in brackets here and then to the power of m. So what we're going to do, we'll do an example here. We'll do a simpler example than the one over there. We've got a squared and we'll cube it. What this means, this cubing means it's a squared times a squared times a squared. So that's our 3 lots there, which is a times a times a times a for the next a squared times a times a. So 1, 2, 3, 4, 5, 6. A to the power of 6. And our shortcut for this is we multiply these two indices together. So a to the power of 2 brackets the power of 3 will become a to the power of 2 times by 3 is a to the power of 6. So in our example over here, we have a to the power of 7 multiplied, here to the power of 3. So here we've got a to the power of 7 times 3 is a to the power of 21. The next example here, we've got here 2 different options. We've got a to the power of n on a to the power of m. We can either have, if n is larger than m, we do a to the power of n minus m, or if if m is smaller than n, we put our n down here and we have a to the power of m minus n. So here, if we do our example here, or if we have here, we'll do 2 examples, a squared divided by a to the power of 4. If we write this out, we've got a times a on a, 2, 3, 4. We cancel and cancel, cancel and cancel. We've got 1 on a squared. Here, so what it becomes is here we've got 1, so here our m was larger, on a to the 4 minus 2 is 1 on a squared. If we do this the other way around, we have a to the power of 4 divided by a squared. So 1, 2, 3, 4 a's at the top and 2 at the bottom. We cancel 1 and 1, 1 and 1. We're left with a squared on 1, which is just a squared, which is our top example here. So what we had here was a to the 4 minus 2 is equal to a squared. If we look at our example here, a to the power of 4 over a to the power of 11. We can do 4 minus 11 is a to the power of -7. Or we can take this 4 down here. And it's a to the power of 11 minus 4 is 1 on a to the power of 7, which we know is the same as a to the power of -7. So looking to our next example here, we have ab in brackets to the power of n. And what this means, we need to apply this power of n to our a and to our b. So it becomes a to the n, b to the n. So here we've got ab in our brackets and our index is -4. Here we apply it to the a to the power of -4, and here to the b to the power of -4. Our next example is very similar. We have a fraction in our brackets, a over b to the power of n. We need to put our power of n, we need to apply it to both the a and the b within the brackets here. So a over b squared, here we a squared over b squared. And with our negative index, we can take it through and make it a to the power of -n, b to the power of -n. Here, or we can flip it over. So here it becomes b over a to the power of n. So what we're doing, we've got a negative index here, so we flip it to the top, and a negative index here, so we flip it to the bottom. It's just saving us a step. And we end up with b to the power of n over a to the power of n. So here, a to the power of a on b to the power of -11. We could apply it through and we'd have a to the power of -11 on b to the power of -11 and then flip them over. Or we go straight through and we flip our a and our b. to the power of 11 and we make it positive, and then we apply it to both parts of our fraction. So the next example we look at, we have AB to the power of negative n. We have 1 here, so it's our negative power here, our negative n here, so it goes at the bottom. So our example is AB to the power of negative 20 becomes 1 over AB to the power of 20. So our next example is just working from our fraction with a negative index. It just means that we can move it to a positive index and we move it to the top of our fraction. So a to the n on 1, which is equal to a to the power of n. So 1 on a to the power of negative 2 is the same as a squared. So the next example we look at, we have negative powers at the top and the bottom of our fraction. And what it is, our a to the power of negative n, we move it to the bottom of our fraction and it becomes a to the power of n. Same with our b to the power of negative m, we move it to the top and it becomes b to the power of m. So here our example, we have a to the power of negative 6, we can move to the bottom of our fraction and lose the negative. Same as what we did before. B to the power of negative 17, we move it to the top and we lose the negative there. So working through here, we're just getting a bit further into these things. We have a to the power of n, b to the power of m, in brackets, to the power of k. And what this means, our k needs to apply to the n and to the m. So we get a to the power of nk and b to the power of mk. So here we've got a to the power of 4, b to the power of negative 9 cubed. So we're going to apply this to both. We have a to the power of 4 times 3 is a to the power of 12. B to the power of negative 9 times 3 here is negative 27. And we could write this here as a to the power of 12 on b to the power of 27 there. So the same works with our fraction here. Our k applies to here, and we multiply them together. So a to the power of nk and b to the power of mk. Our example here, we have a to the power of 6 over b to the power of 5 all squared. We apply this to both parts. We get a to the power of 6 times 2 is a to the power of 12, and b to the power of 5 times 2 is b to the power of 10.